Hello everyone, Dr. Data Science here to teach you data science methods and tools today, tomorrow, and beyond. The goal of this video is to teach you the basics of object-oriented programming to build neural networks using PyTorch. Throughout this video, we are going to briefly review objects, classes, attributes, and methods, also constructors, inheritance, and all these tools that we need to understand the NN.Module, which is the base class to define neural networks in PyTorch. If you like this video, please don't forget to subscribe to the Dr. Data Science team so others can find this video. There are two main programming paradigms. The first one is procedural programming. This is when you code as a sequence of steps. Let's say we import NumPy as NP. You know that NumPy is a data science toolkit in Python that you can work with multidimensional arrays. Here, for example, we have an array with two elements in it, 4 and 5. And then in step 2, we are going to add them together. In step 3, we are going to print this result, right? So this means that every time you have to repeat this process when you get a new set of inputs here. On the other hand, we have something called object-oriented programming, where we look at the code as a collection and interaction of objects. We have to define objects, but one example of this is NumPy. For example, NumPy allows you to create multidimensional arrays that they have some properties, and you can also perform some operations on them. Therefore, objects are very important because we can build versatile and reusable tools and frameworks. And it's very useful even for defining different types of neural networks, as we're going to see when discussing PyTorch. Let's start with this question. What is an object? An object is a data structure incorporating information about state and behavior. What is a state? A state tells us how the object looks or what properties it has. On the other hand, behavior tells us what the object does or how to operate on the object. Again, I want to look at the example from NumPy because most of you are probably familiar with this. We create a two-dimensional array that we printed here. You can see that A has 3 rows and 2 columns. Then we are looking at A.shape, which tells us that this array here has 3 elements in the first axis or dimension and 2 elements in the second one. So this is exactly what the state means. It means that it tells us how this object looks or what properties it has. Now, let's say that I want to take this original object and change the number of elements in each axis or dimension. Here I can use this function or method, which is called .reshape. And now we say that we want to have 2 elements in the first axis and 3 elements in the second axis. So in this way, we can change the shape or the state of this object by using this behavior that we have defined here. So just to recap this, an object is a data structure incorporating information about state and behavior. And the nice thing about object is that we bundle these two together. And this is what we call encapsulation. So this is one of the core principles of object-oriented programming, that states and behaviors are together. For example, in the previous slide, we saw that we have a state, which was the shape, and then we had the behavior part, which was when we use reshape, that we could change the state of the object that we had. And more common names in Python for state and behavior are attribute and method. So we call a state attribute and we call behavior method. So these are the names that, for example, when you work with data science toolkits such as NumPy or scikit-learn, you see all the time. So now you know exactly what these two are. And something to keep in mind is that attributes are variables, as you saw in the previous slide. For example, the shape of a NumPy array was a tuple that we had. And methods are exactly functions, right? And that's exactly for behavior methods. We use parentheses because anytime you define a function in Python, you need to have parentheses. And if you remember from the previous slide, for finding the shape of the NumPy array, we didn't use any parentheses. And that's because here we are just looking at some properties. We are not performing any operation. So that's something to keep in mind. So far we defined what an object is. But what is a class? So class is a blueprint or template for creating objects that have different states and behaviors. Let's look at this in a very simple, intuitive example. Let's say that I want to define a class called customer, and each customer has a name attribute, right? So each customer is identified by a name. So in this case, I can define a method or function, which is here we call set_name, and I pass an argument here which is called new name. So anytime I call this set_name and I pass a name argument to this, then I set this attribute.name to be equal to this name that I just passed to this function. Something that is confusing, and I see a lot of confusion around it, is why we are using this self here as the first argument when we are defining these methods. The reason is this: when we are defining a class, we do not have any instances from that class yet. And that's something that is going to be created in the future when you want to define or create your objects. So that's why this self is called an stand-in, which means that what it does is that means that when we create sort of like an object, now we want to have this, for example, .name attribute. So you can use any name that you want. This is not a keyword. You can use any other name you want, but to follow best practices in programming, you are recommended to use self here. But we need to have this self to represent the object that we are going to create in the future. And also here in this definition of class that we have, because I want to be able to show the name of the customer or display the name of the customer, I define another method or function which is called display_name. And look at here, we are only passing the self argument here, because here we are not trying to perform any operations anymore on for example, like creating a new name or anything like that. The only thing that we are trying to do is just print the name. And that's why you can see that we pass the self argument and then we say print name and then we add self.name. So after we define this class, now we can have two different instances or realizations of this class, which we call them objects, right? So on the left, we have C1. At first, we initialize it, and then we use .set_name. And let's say here we pass the name Alex, and we also display it. So you can see that this name now is sort of like displayed correctly. On the right side, we have another object or realization. We use .setName, and here we use Anna. And you can see that now we can, again, display this name. So we created a class, and now we have two different realizations, and we can have as many as we want. There is one problem with what we have here, and that's that here we have to first initialize this object or instance of this class, and then we have to use the method set_name to set the name of the customer. It would be nicer if when we create an instance of this class, we can automatically add the name, because we know that every customer should have a name, and that's something that it should be there. And that's when we need to use constructor. So the constructor, which is here underscore underscore init underscore underscore, is called every time that an object is created. So the nice thing here is that you don't have to explicitly or directly call this method, and that's something that will be done in the background. So how can I convert what we had in this new form? So you can see that now I have on the right side this def, because again it's a method or function, so we always need that a statement there, and then we use this underscore underscore init, and remember self should be always there, and now we have this input which is new name. And other than this, everything is very much similar to what we had before. So how is this different? So you can see that now when I define or create the object, I can just pass the name Alex or Anna, and this way I automatically set that attribute name to be to the desired name that I want. So this really simplifies the process. So far we know one of the key things about classes and objects, right? Which is encapsulation, meaning that attributes and methods are bundled together. The second one, which is extremely important, and that's exactly why we need it for PyTorch, is inheritance. Inheritance means a class derives from another class, meaning that you have a parent or base class, and then now you want to have a new class which we call a child or subclass. In PyTorch, we use mainly the name, the terminology subclass. And the nice thing about this is that you can share attributes and methods of the parent or base class with the subclass. So let's say we have this class which is called Customer, and in this case we have the constructor for initialization, and then we define another method which is called give discount. So let's say you want to give an amount of discount to each customer, and in this case, what happens is that you can see we pass the amount, and then we add that to the discount attribute that we have here. But now let's say that we have another class of customers which we call them VIP customers, right? So that's why you can see that we have the statement here, class, and then the name of the subclass, and in the parentheses we put the base class or parent class, the one that we want to derive from. And the important thing is that here, when you want to use constructor to initialize your objects later on, you can always use the ones that they have been defined before, so you don't have to repeat every single thing. So that really helps in terms of being able to extend what you already have. And the way that we can do this is using this super.init, right? So if you look at it, we have here super, and then we have the name of the subclass, again, self, which should be there, .init, and then we pass these to sort of like, input arguments, name, and the initial discount that we want to give to any customer. And something that I forgot to mention earlier is that we put discount, the default value, to be 0. So meaning that if we don't pass any information about discount when we create an object, then the default value is 0. And so the nice thing here is that we previously, in the first class customer, we defined this method which is called give discount. Now for VIP customers, I want to keep what we already have, this give discount, and I want to create a new method which is called give special discount. And what is special about this? The special part is that now if you give an amount, we want to give 2 times that amount as discount. So what do you think will happen here? When you're using VIP customer, can we still use give discount, which was part of customer? If you answer yes, you are correct. So let's look at this. So here we have the VIP customer class, which is derived from customer. Now we're going to create an object, this time for Anna, and we want to see the initial amount of discount, which as you can see here is 0. And now we use the method which was give discount, which we didn't even define it here. This is something inherited from the base class. And you can see that it still works as it was supposed to, right? Because when you say give discount 5, means that you have to add this amount to the sort of like attribute discount. But now let's look at what happens if we use the new method for VIP customer class, which is give a special discount. And here, if I add 5 this time, now it will be doubled and we give 10 discount to this customer, right? So as you can see, this means that we can still use give discount and give a special discount, and they're compatible with each other. We don't have any problems. We don't have to repeat everything that has been already defined in the parent class. So that's great. So what does this mean in terms of building neural networks in PyTorch? So this means that in PyTorch, we have the base class, which is torch.nn.Module. And now when you want to define your own neural network or own deep learning model, now you use subclassing. So here we are going to import torch, and then from torch we are going to import NN. Here we are using CPU as the main device because this is like just a simple demonstration, but you can also, if you have a GPU, use that. So now we use again the class statement, the name of the subclass that you want. So this is the name that you have to choose. And then inside parentheses, this should be the base class. So this must be nn.Module. So remember, the first thing is the constructor part, because you want to initialize this model that you have here, this class that you have here. And again, we are using this def init. And in order to use, or in some sense, inherit from the base class, we are using this super. So super, the name of the child class or subclass, self.init. So here we are not passing any arguments, so that's why you can see that this parenthesis is empty. Then I'm gonna create an attribute which is called flatten. So the idea here is that if I have, let's say, an image of size 28 by 28, and if you want to use a multi-layer network, then you have to first flatten this two-dimensional image to be one-dimensional. So that's what this nn.flatten does. And then I'm gonna use a sequential model where I have, because here we are assuming that the input image is 28 by 28. So I have a linear model where I have 784 or 28 square input neurons. And then I have 512 in the first hidden layer. And then I have another 512 neurons in the next hidden layer. And then finally, I put 10 neurons in the output layer. So what this means is that here we are basically trying to do classification where the input is 28 by 28, and we have 10 possible outputs or classes. But please don't confuse this class with the class that we use from the programming side. And here also we are using some nonlinear function, which is the rectified linear unit. And remember that here, when you define your network, you don't have to initialize these weights or parameters because all of these things are already inherited from the base class or the parent class, which is the nn.Module. The only thing that we really need to do in these cases is to define the forward model, right? Meaning that if I have an input X, what this model wants to do with that, right? So we know that we have this self.flatten. And here we are gonna first apply this to X, and then we are gonna have this self.linear stack. That's the name that we give to this sequential model, and this will create the logits. In the next 2 slides, I'm going to show you why we call this logits, but for now you can think of this as just a nested function that you have the input, you give it to flatten, and then to the linear ReLU stack, and then this gives us some output. And don't forget to use return because this is a function. And the really nice thing here is that if you look at it, we don't define the backward pass, which you need for back propagation or finding gradients, because all those things are part of nn.Module. That's the main beauty of using PyTorch and why it's so popular. So after we define a class, now we need the object, right? So we need to create an instance or realization of this class that we defined in the previous slide. And we can do this here, as you can see, by neural network. And then here inside parentheses, we don't pass anything because all of those things are already in the definition of class. And then the nice thing is that in PyTorch, you can always use print on the sort of like, neural network that you have. And it gives you information about all the layers and the structure of your network, right? So it tells that you have a flattened layer, and then you have this sequential structure with these layers. So you have two linear sort of like layers, or what we call as dense layers, and then the last one that you have for your output layer. I like the fact that PyTorch uses in features, out features, so it tells you exactly how many features are coming, how many are sort of like, being produced at the end of the layer. And this is part of the tutorial that you can see on the PyTorch website. So I give the link here if you want to also work with this sort of like neural network model that you can see here. But what I want to emphasize here is that, for example, these model parameters or model weights are already initialized due to inheritance, which is very important when you're working with classes and objects. You can see here we create a tensor, which is from torch.nn. And the way this works is that when you work with images, we usually have a three-dimensional tensor where the sort of like the sizes are number of samples, height, and width. So in this case, we have one image of size 28 by 28. That's why we set the first one to be 1. And then we pass this to this neural network model that we have, which if you remember, we call it model. So now we can print these logits, which is the output of the model. And then if we want to sort of like translate this into probabilities, now we can use nn.softmax. And just give you a very quick idea here why we are using softmax is that when you have a classification problem and you have a neural network model, the outputs in the last layer, they should give you probabilities. And the way that we can convert a set of real valued numbers to a valid probability distribution is one of them is using this softmax function, which we take the exponential of each element and then we divide it by the sum of the exponentials of all elements. So this guarantees that each output is between 0 and 1 and the sum of the outputs is 1, which is basically from the three axioms of probability. So that's what you can see that we have here. So the logits are exactly the real valued numbers that we have before using the softmax. And then after we apply the softmax, then that's where we get these probabilities, which we call here pred_probability. And the nice thing here is that now, because of the way that we define this using class and attributes and states, you can see that now we can look at model.named parameters. So this is, if you look at it, this has double parentheses. So this means that this is a method. And this method gives us the names of the layers and also the parameters that they have for each layer. So you can see that here, for example, the first layer is this linear ReLU stack. And then we have both weights and bias, right? Because for neural networks, we have both weights and bias for each layer. And you can also see the size or shape of the weights and biases for each layer. So this, for example, size, when you use like dot shape, that's the attribute or a state because it tells us how this object looks like. And then here also we have name, which gives us the name of this object. I hope you found this video helpful, and please don't forget to like and subscribe.